So this is a difference between linear regression and nominal regression, logistic regression. This is for predicting. This is for recognize discrete. Because no, Likert, no, Likert scale is not Likert none. Yeah, Likert 1 to 5, right? 1 to 5 is the place you choose. You choose the first place. That means you disagree very much. If you got 5, that means you agree very much. That is location. 1, 2, 3, 4, 5. That continue. Yeah. Yeah. Linear, for example, catch. Okay? If here is a catch, you want to assessment, you want to calculate some population of fish, their crop, yeah, the catch, how much. You can use this to predict, for example, the current speed is lower, the temperature is at a 25 degrees. It's very suitable for fish migrate here. So I predict under this condition, they will the fish will come in here. I predict, and when the fish come in here, I predict, I forecast, maybe how much ton you will catch. That is for predict. That is linear regression. But this recognize or discriminate is, for example, I want to discriminate this one is criminal or not criminal. I can use some questionnaire to test him, right? Yeah. Or using some method to test someone, and then I will know you are honest or not. Understand? That is the recognize. You think you have many questions, right? You understand what I'm speaking about that? So depend on this. If y, I remember, I say again, if the y is a nominal variable, that is logistic. If the y is a continuous variable, that is the linear regression. That is quite different. Okay? Yeah. But before we cut this, we can do one thing. That is factor analysis. Why we have to do factor analysis? Why? Because every variable in our definition is a dimension. If all of these variables, they are if suppose, I say suppose all the variables are independent, then we will have n dimension. Or if we have n dimension, we want to analyze this, it will make our analysis more and more complicated. So we have to reduce dimension. But how to reduce dimension? We're using the factor analysis to help. But what about the factor analysis? The factor analysis is correct all the variables. They have the same relationship. They are consistent. Okay. For example, sea temperature, salinity, they are very consistent. They all all of this maybe we can compose together to be a factor. And this factor, we call that C condition. Okay? Or maybe this one. Air temperature and raining, maybe we can compose together to be air or the weather. To be a weather condition. This is a factor 2. So we can rewrite after factor analysis, we can rewrite our regression as A plus 2. Maybe only 5. Okay? Factor. So after factor analysis, we only got 5 factor. This 5 factor can explain everything. Can explain this everything. So this procedure we call that factor analysis. Okay. So factor analysis is actually a method to reduce. Okay. And how about the SEM? XCM actually is a model-to-model analysis. This is a dimension. But you can say that it's a model. You also can say that is a facet. Okay. Model-to-model. Model-to-model. Actually, a model, you can see that in facet. You can say that also as a dimension. That is same. Okay. A model, a facet, a dimension is same. Okay. But what is the model? The model is a lantern. How about the lantern variable? What is lantern? It's very hard to explain. For example, attitude. Attitude, right? Attitude. 态度. How to do? Yeah, behavior. Okay. Yeah, behavior. Yeah, behavior maybe affect that you are. Yeah, before maybe you are affect your action. Yeah. Right? For example, you are lazy, you will not do that. If you are industrial, you will do that, right? Yeah. But this is imagine variable. Imagining. It is latent. It's not so easy to measure. right? But this is what we call model. Uh, for example, change. Oh, change. Oh, no, no, no. Change, okay? Lucky. Lucky, right? Oh, actually, I'm very poor, so I don't have money to attend the school. But someday I meet someone, a rich man, like uncle. He liked me very much, and he give me 1 million. Oh, I can go to the school. Yeah, and then I become a professor. I appreciate him very much. So change. This is a cannot measure, but it may be happen. It may be not happen. So SEM is more advanced analysis method for this one. Now we are talking about the regression. Actually, this is one kind of regression. How you will affect this one directly. How you will affect indirectly. How? How much? How much? How much? How much? Okay. Actually, it's very similar. Very similar like this. Okay. But this is bigger. Why is it bigger? Because behavior is a imagination, you know, a non. Yeah. Okay. Yeah. But each model at the least have 3 items. At the least 3, because 3 points can decide a dimension. Only 2 points, just a line, a length, a line, so cannot decide a dimension. So at least, if you want to analyze SEM, every model at least you have to decide 3 to 5 items. Cannot lower than 3, because 2 only can decide 1 line. 3 can decide a dimension. Okay. So today we stay here. We compose many variables together to be a factor. Actually, this factor, this is a dimension. This is a dimension. This is a dimension. This is a factor. And you can also say this is a model. Okay? But this is a very, very simple linear model. This is not linear model. This is not linear. This is a linear. This one. This is a multi. Yeah, multi linear. Not multi regression. Yeah. This is what we call GLM. General linear model. Okay. This is what we call GAM. General added model. What we call general added, because we can edit some model at any time. So this is general added model. Okay. Understand? Yeah. No, we start from here. Okay. Uh, DBT file, you can, I asked Miss Sari, she will put on the website, okay? I'll give you, okay? The purpose of the factor analysis is to define the potential dimension. Potential dimension is this. This is what I call potential dimension, okay? Since potential factor such as morality, courage, this is imagine morality and the morality the ratio of the die, right? Morality and courage, that is imagine variable, okay? So cannot what? Cannot directly measure, okay? Cannot. So we can use the fixed factor analysis to explore the structure component, of this concept to define the structure. So this is a structure. This is also a structure. This is a linear structure. This is an added structure. Okay? So SEM is what we call structure equation model. Structure equation model. Okay? The dimension, the facet, this is 10, okay? The dimension or the facet of each dimension contains those variable. Every factor contains some variable. So this is what this x1, x2, 2xn is what we call variable. But f is facet or dimension or factor. You have the clear consent, okay? And also facet is also can be model. Okay? The use of factor analysis after confirming the structural complement, we often use factor analysis for summarization and the data reduction. Okay? Okay. We will introduce them as follow. First, summarization. After all variables are analyzed by factor, a few constants can be obtained, which are equivalent to summarizing all variables and after proper naming. After proper naming, what is proper naming, right? Name. Oh, after the factor analysis, we got that F1. F1 include this, and this is C temperature, and this is C salinity. Oh, water salinity. Oh, this is composed in the factor 1. We give this factor a name, maybe just as I say, C condition. Oh, the air temperature blending, they composed to be F2. So I give the F2 a new name as weather. Okay. Yeah, yeah, yeah. Heightened, yeah, yeah. After proper naming, they become what we call factor. Okay? So this is a fast. Data reducing. We can select a representative variable after factor analysis. This representative variable still have most of the explanation, have the most of it, the explanation of the original variable. This have the most explanation of the variable. Okay? And also retain the original structure. That means this can represent this too. Okay? Therefore, through factor analysis, we can get data reduction function. Before factor analysis, our dimension is from S1 to Sn. But after factor dimension, after factor analysis, our regression is from A1 to A5. It reduces a lot of the data, okay? That is what we call data reduction function. Okay, before performing a factor analysis, the data must be tested, okay, for compliance with the following four basic statistics. Should be compressed with the following four basic statistical assumptions. One is a linear regression. The correction coefficient of the two sets of variables is based on a linear relationship. If it is not linear relationship, the variable need to be transformed to achieve a linear relationship. What do you mean? Because this is a linear regression, okay? If there, oh sorry. I don't play it because they were cut off the screen. If two set of variable is should be based on a linear relationship, that means this one and this one, they should be a linear relationship. If they don't have a relationship, we have to transform the variable maybe to reverse, inverse, or square, or find the root mean square. You understand? Transform. If they don't have the linear regression, maybe we'll transform the factor to just say reverse, or we transform to logic or normal logic. Yeah? Maybe we transform this to be transform this, or transform this one. Or reverse, okay? Or square, or Rubin square. Yeah. We have to transform this. But we have to try. Yeah. Before, you have to try many times, but right now we have the SPSS. Don't worry. They will give us the very faster estimation. But I will explain this, okay? So every set of the variable should based on a linear relationship. If they don't have the linear relationship, we cannot compose this regression. Okay? Yeah. One by one. Yeah, one by one. Yeah. But you don't know how about that, right? There is a very simple concept. For example, the range of x1 variable, for example, from 1 to 100, okay? But x2, the range, you know range? Range is the maxima minus minima, right? Range, okay? Okay. For example, x2 is range, maxima minus minima is from 10,000. Oh my God. So here it's only 1 to 100, right? 1 to 100. But this is from 1 to 10,000. Right? So we cannot compose together easily. You understand? So we have to reduce this. How to reduce the range? Because its range is very large. So maybe, just as I mentioned, maybe you can reverse, maybe you can transform to square, to Rubin square, even take a log. So if you will take a log, they will from 0 to 1 to 5. The range will become from 0 to 5, only 5. This is 10. There. So the range will reduce from 0 to 5, from 10,000 to only 5. That is what I say is transform. You understand? Yeah. Yeah. Okay. Second, normality. Normality, that is always, okay. Although the canonical correction does not strictly require normalize the distribution to allow higher correction between variables. So normality is better than the normality is difficult to interpret. So most of them require normality for a single variable. Actually, linear regression is the data should come from the normal distribution. But the logistic regression, the data maybe not come from the normal distribution. Maybe not come from, okay? For example, if you want to apply a credit card, you want to go to the bank, you want to apply a credit card, okay? Uh, they will ask you to fulfill a table, okay? Include what? Include what about your education, your gender, okay? Education. And gender, only male or female. So this is a nominal. Male or female. 1 or 2, 1 or 0. This is nominal. So this is a logistic. But maybe they need your incoming. They need the information of your incoming. Oh, this is a continuous variable. But linear, almost all of this should be what? Should be continuous variable. Understand? Almost. They should be continuous. Okay? Why? Because they need to be of normative. But you say here, it just require, no? Just require, not must. Because if we give me a nominal variable, it's difficult to interpret, difficult. But it didn't mean you cannot use. You can use, but it's difficult to interpret. Homosexuality. Oh my God. If they are not equal, the correction between the variable will be reduced. So it's necessary to meet equality of variable. Here, what it is, almost of the variable, their variance should be same, similar. Okay? Just this. In Chinese, we say, I hope you can learn the Chinese. The Chinese is very easy to explain it, this one. But some years after, you will understand what it means. That is homocentric theory. Okay. Homogeneity of a sample. Sample with the same property will produce a multi-collinearity. Since factor analysis is used to identify relationship between variables, and moderate multi-collinearity is required. That is, items under the same facts should be higher. This is more important. Items under the same factor should be higher corrected. So, very short. We use a lot of time to discuss about the center fishery. So, so I will give you an example, but the time is short. Maybe next time we use we're doing a vector analysis. I give you an example. Okay. Yes. Today I will appreciate all of you join our visiting of the fishery center fishery ground. I hope we can have a more good communication with the Taiwanese student. Okay. I also hope everyone you can maybe bring 4 or 5 Taiwanese students to be your how to say yeah member, team member. Okay. Yeah. Yeah. Okay. Yeah. 4 or 5. Yeah. Communicate. Yeah. You compose a small team. Okay. Yeah. But I will hold the activity beside the visiting. Maybe the coming festival is the Middle Moon Festival. You know Middle Moon Festival? Yeah, Middle Moon. 中秋节 Middle Moon. Middle Moon Festival, okay? So I also want the Taiwanese student, they will prepare some about the Middle Moon Festival cake. A cake? Yeah, moon cake, right? I think in mainland you also have the moon, you have, right? Indonesia have a Middle Moon Festival. You have cake. But not at the same day, right? Same date. August 15th, no? No? Every day. No, I say lunar year is August the 15th. In Chinese, for Chinese people, we have the Middle Moon Festival. In Greek, no, you don't have. Yeah. So, for example, the coming festival, I will ask the student all of you, we may hold a meeting to discuss how we celebrate about this. And the Taiwanese student, maybe they will prepare cake, cake, and maybe you can prepare also like barbecue again, okay? And how about the Indonesian food? Yeah, we can communicate. All about the material, I pay, okay? Don't worry. Yeah, because I'm fat and I have a lot of money. Don't worry about it. But I want to communicate with our student. Actually, I have a selfish thinking about that. I want our student, our Taiwanese student, can speak. Yeah, not there to speak English. You know, Taiwanese student is quite different than the Chinese. You know, the Chinese student is very noisy. Go anywhere. The Chinese. But Taiwanese students always keep silent. They like to be aligned, you know, to nine. Or, yeah. They always keep. Any question? No. But Chinese, I have question. Oh my God. So this is quite different. The Taiwanese students always. So they cannot improve their English ability. So I want to make friends with you. and speak out the language. But please don't laugh at them because their English ability is very poor. Okay. Yeah, that is. But I want to practice. And I will say thanks to you first. No problem. Okay. So you can also learn the Chinese with the student. Yeah. But I think you live here for many years, right? So you can speak very well. 一点点. Yeah. Yeah, very humble. But I'm going living here for 3 years, right? But it's still a little, 一点点. Can you say something to her? 一点点. Always 一点点. Okay, I will hold or open more and more activity to communicate with our students. And I will appreciate all of you to help our Taiwanese students improve their English. Taiwanese students to silent, yeah, to shine, yeah, like me. I'm also very shy. Okay, thank you very much for coming, Uncle, Mr. Uncle. Thank you for your always you. If you don't come, I will go to see you, call you in the dream tonight. But today I will give you a peace night. Okay, peaceful. Thank you. Bye.